Okay, so the average rate of change is like the slope, and if you remember back in like I think 7th grade is when you guys learn the slope, is when you take like the rise over the run. Yes, what? Well, yes, y equals mx plus b, but it's just the m part of the equation. The slope is the m part of the equation. And so we calculate that by taking the rise over the run. So if you think about the rise, it goes up and down. So that's talking about like the y values going up and down. So the change in y over the run is the x-axis. So it's the change in y's over the change in x, okay? But for math 3, we're going to be looking at polynomials, okay? So because it's not a straight line, we can't call it a slope because it's not a constant slope. It changes between each point, so that's why it's called an average rate of change, okay? So for prior knowledge, we are asked to find the slope between the 2 points. So the 2 points are given to us. We have to figure out the coordinate points, and then we'll go from there, okay? So if we look at this one at the bottom in pink, I just highlighted it in pink. To get the coordinate, remember as x comma y. So at the bottom right there, my x value on the x-axis, that's a 0. And then on the y-axis is at -2. So that coordinate is 0, -2. And then I need the other coordinate up here. The other coordinate is 1, 2. My x value is 1 and the y value is 2. So in order to find the slope, there is a formula that we have for slope. That's the y2 minus the y1 over the x2 minus the x1. Does that sound familiar to you guys? You don't remember that formula? Okay. Some of you, yes. I know it's been a while. I think you learned this in like 7th grade, possibly. I don't know for sure, but I think it was in 7th grade when you learned this. So you need to get a coordinate point, and because you have 2 of them, one of the coordinates would be the 1s and the other one would be the 2s. So for example, the pink one, I like to personally go from left to right. So the one on the left is the pink one. So I would call that one x1, y1. And they both have to have 1s because it's the same. It's like you're saying that's the first coordinate. That's the first x and the first y. And then for the blue one, I'm going to call that one like x2, y2. So when you learn this, hopefully, if you remember, you basically take the value and you plug it in. So I have the y2 and the x2. Notice that the 2's go on, like they're stacked on top of each other. And then the 1's are stacked on top of each other. It's the y1 and the x1 go at the end, okay? So my y2 value is a positive 2 minus my y1 value. Y1 is the pink one. That's the -2. So because that's a negative and a negative, I'm going to put that in parentheses, over my x2 value is in blue, the blue one. X2 is 1 minus my x1 is the pink one is 0. So all I did right now was look on the graph for my coordinate points. My y2 was right here, is 2, minus y1 is the pink one, -2, over x2 is the blue one, is 1, minus x1, which is down here in the pink, is 0, okay? So I just got the formula, got the correct value, and I plugged it in. The one right here, I put it in parentheses again because you're subtracting a negative, so we need to do negative times the negative, or we can do keep, change, change, okay? Have you guys heard of keep, change, change before? Yeah? Okay. So we're going to keep this sign as positive, And then we're going to change this to positive, change this to positive. So keep, change, change. So keep the 2 positive, change that to positive, change that to positive. Or you can think of it as a negative times a negative would be a positive. So for my numerator, that's going to be 2 plus 2 gives us 4 over 1 minus 0 is 1. So my slope is just going to be 4. The other way you can do it is rise over run. So how many times does it rise? It rises 1, 2, 3, 4. We're going up 4. And then you run 1 time to the right. So up 4, right 1. It's 4 over 1 gives you 4. But sometimes people get those mixed up and they'll do like 1 over 4 instead of 4 over 1. So, but for the sake of class, we're going to be using the formula instead of thinking it as rise over run. We're going to use the formula instead, okay? So for the math 3, it's basically the same thing, except we're going to be looking at functions like polynomials. So we're going to use f of x instead of y, okay? So for concept, we have this on your notes. The average rate of change is the average change between the y values for each unit of x over a specific continuous interval. So if you remember, anytime you see this word right here, interval, that means you have both x's. You have a x1, comma, x2. Anytime you see the word interval, it's 2 x values there, okay? 2 x values. And then it says that the average rate of change for an interval corresponds to the slope of the line through the 2 points. And so if I look at the coordinate point here, 1, 0, and 2, 10, it would be like if I draw a line between those two, connect them, what would be the slope of the line? That would be your average rate of change. And then you can see it's the rise over the run. The change in y's is 10, and the change in x's is 1. So it's 10 over 1 gives you 10. But again, we're actually going to be using the formula rather than like actually just taking the rise over run, because sometimes on the graphs the scale goes by 2, sometimes the scale goes by 3, so it just depends. And so you got to be super careful with that. So instead, we're going to use the formula, which is what the skill here is saying. So my skill is to find the average rate of change of a function over a continuous interval. And then I'm going to be using color here. So my x1, I'm going to be using pink. And the x2, I'm going to be using blue. So if you have 2 numbers in your interval, the first one is going to be x1, and then the second one is going to be x2. So our step 1 is going to be to calculate. So calculate, meaning they're not always going to be given to you, so you're going to have to find it. The corresponding values for x1 and x2, meaning we're going to be calculating f of x1 and f of x2. And if you remember, with function notation, f of x is the same thing as a y. So when we say f of x1 and f of x2 is the same thing as saying that that's like a y1 and a y2. It's the same thing, and we're just using function notation, okay? So then in order to calculate the average rate of change, we're going to plug it into the formula. So our formula is going to be this over here, f of x2 minus f of x1 over x2 minus x1. That's going to be our formula there. It's basically, again, the same thing. It's y2 minus y1 over x2 minus x1, but it's function notation, so we use f of x, okay? So again, this is the same thing as like y2 minus y1 over x2 minus x1. But because we're looking at functions, we got to use f of x's. So let's look at our first example. I believe that's all written on your paper, so you don't have to copy it down. So the directions say to find the average rate of change for the function over the specified interval, and you're supposed to give exact values or round it to 3 decimal places if needed. We will have decimals today, and we will, like, this example is going to be exact values. So let's practice, or let's go over this one together since you haven't really learned how to do it yet. If I go back to step 1 on the steps here, you have to find f of x1 and f of x2, okay? And then if you remember, x1 is going to be the first number on the interval, x2 is going to be the second number on the interval. So in this example, my first number on the interval is a -1, and the second number is a +1. So this is telling me then that -1 is going to be x1, and the +1 is going to be my x2. So the first thing I want to do is calculate f of x1. So first, I'm going to calculate f of x1. But my x1 value, again, is a -1. So this is going to really be f of -1. Again, that's because my x1 is -1. So everywhere I see an x, I'm going to plug in -1. So this is going to equal negative. The negative is outside. And then I'm going to do parentheses because I'm plugging in a -1 squared times parentheses -1 minus 4. Okay? So this is going to equal a negative parenthesis. What's -1 times -1? +1 times parenthesis -1 minus 4 is going to be a -5. Because I'm subtracting there. I'm not multiplying in the second, like in this here. We are adding and subtracting. So -1 minus 4 gives me -5. And then that's negative times 1. That's going to be -1 times -5 is going to give us a +5. So now I know that f of x1 is going to equal 5. And I'm going to need that later, so I'm going to highlight it. F of x1 is equal to 5 because I know I'm going to need it later, okay? You guys can like circle it, underline it, or whatever. We're going to need that value later. All right, then we got to do the same thing for x2. So the second thing I need to do is do f of x2, which is the same thing that I did for the first time, but except this time I have to plug in 1. My x2 is 1, so everywhere I see an x, I'm going to plug in a +1, okay? So this is going to be f of 1. And now everywhere I see an x, I'm going to plug in 1. Okay, so then I have a negative out front, and I'm plugging in a +1 times parentheses 1 minus 4. And this is where you got to be super careful. People always mess up here because they want to put this in the calculator. If you put it on the calculator, the negative has to go on the outside, then you use a parenthesis, okay? But 1 squared, you can just do that. 1 times 1 is going to be 1. but then you have the negative out front. So this is going to really be a negative 1 times 1 minus 4 is going to be negative 3. And so when you calculate those, this is going to be a negative 1 times a negative 3. So what do we get? Positive 3. So then I know that f of x2 is going to be positive 3. And I'm going to need that one again. So I'm going to highlight this one because I know that I'm going to need it. That's my f of x2 is going to be 3. Okay. Then once I have those two values, then I need to calculate the average rate of change. So for the average rate of change, I'm going to use my formula is, let me zoom in a little bit. My formula is going to be f of x2 minus my f of x1 over my x2 minus the x1. Okay, so I'm going to take my f of x2. What did we calculate for f of x2? F of x2 is 3. So I got to plug in a 3 minus, what is my f of x1 value? 5 over, look at the interval up here. If you look at the interval, what is the x2 value? Positive 1 minus the x1 value. What is my x1 value? Negative 1. So because we're subtracting a negative 1, I'm going to have to put a parenthesis. So this is going to be minus parenthesis negative 1. Because I'm subtracting a negative. And then so then here it's just calculating my numerator. 3 minus 5 is going to give us what? Negative 2. Over at the bottom, because of the negative and a negative, it's keep, change, change. So keep that positive, change this positive, change this positive. Or you can think of it as negative times negative is a positive. So 1 plus 1 is going to give us 2. And then negative 2 divided by 2 is going to be negative 1. And then for your answer, you can't just say it's negative 1. You got to answer it properly by telling me what the interval is and what you just calculated. We just calculated the average rate of change. But instead of saying the average rate of change, blah, 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 I'm going to abbreviate that to AROC, like the average rate of change between my interval, negative 1, 1, is equal to negative 1. And your answer is very important for you to tell me the interval because the average rate of change changes between each interval. Each interval is going to have a different rate of change. So your answer, you need to tell me what the interval was, okay? Cell phones put away, you guys. If I see them, I'm taking them. They're going on my desk for the rest of the period. All right, so I forgot to mention though that this is actually, if you notice the function, it has like a GCF of that negative x squared up front with the binomial. That is called a factored form. So this function is in factored form because I have the parentheses with the binomials. But the next example is not going to be in factored form. That one is going to be in standard form. So we'll see that next example right now. My next example here. Well, actually, before I get to that, I know I basically talked the whole time And I don't know if you guys fully understood like the whole process. So I want you to have a conversation with your partner. I want you guys to first discuss how did I get the f of x1 and the f of x2? Like, what is the process for that? Can I have righties tell your partner, how did we find f of x1 and f of x2? How did I do this right here? All right, so let's go ahead and look now at the second example. The second example, notice it says f of x equals x to the fourth minus x cubed minus 3x squared plus x plus 2. Notice I don't have any like binomials inside parentheses. That means that this is actually in standard form. So this is not factored. This is in standard form. Just because I don't have any binomials in parentheses or trinomials, so they're not factored. This is in standard form. All right, so the directions again, same directions. We are finding the average rate of change over the interval, and we need to give exact values or round to 3 decimal places. I will say because of that 1.5, we are going to have to round, but word of precaution, for your answer to be accurate or like the most accurate as possible, we need to round until the very end, okay? So do not round until the end, okay? Do not round until the very end, okay? Because if you round too soon, then your answer could be off because you are going to have a rounding error in your answer. So do not round until the very end. All right, so let's go ahead and get started. The steps are the same. First, we got to find f of x1. Can I have lefties tell your partner, what is your x1 value? All right, on a count of 3, everybody tell me what is x1. Tell me in 3, 2, 1. 0. It's the beginning of the interval. It's our x1. So I'm going to plug that into the formula or to the function. Step 1 is to get f of x1. We are going to plug in 0. This is going to be f of 0 equals. Everywhere I see an x, I'm going to plug in a 0. So this is going to be parentheses 0 to the fourth minus 0 to the third minus 3 times 0 squared plus 0 plus 2. So everywhere you see an x, you have to plug in 0. And because that one is 0, you can just do that one mentally there. What's 0 times 0 times 0 times 0? 0. Minus 0 times 0 times 0? And 0 times 0 times negative 3? 0 plus 0. So all of this is 0 plus 2. That's going to give us 2. So this is f of x1. That's all just going to be 2 right there because the whole beginning part ends up just going away. And again, I know I'm going to need this value, so I'm going to highlight that one. All right, then we got to do the same thing for x2. So now, righties, tell your partner, what is the x2 value? Okay? On a count of 3, everybody tell me what is x2 in 3, 2, 1? 1.5. Thank you. So my x2 is 1.5. So I'm going to do the same thing that I just did for the first one. I'm going to go plug everywhere I see an x, I'm going to plug in 1.5. Okay? So I see an x, 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 x. Everywhere you see an x, you're going to plug in 1.5 this time. Okay? So the second one we're going to do is f of x2. That's going to be f of 1.5. That's going to equal 1.5 to the fourth, parentheses 1.5 to the fourth, minus 1.5 cubed. It's like zoomed in too much. I can't see. Sorry. Minus parentheses 1.5 to the third power, minus 3 times 1.5 squared, plus 1.5 plus 2. All right, and then this one, you can just plug that whole thing into the calculator, and you can get your f of x2 value. So just plug it in everywhere you see a parentheses on the equation. You're going to open a parenthesis on your calculator, okay? So you're going to go parentheses, 1.5, close the parenthesis. And then to get to the fourth power, you've got to put the little tenth key, the caret key. So 1.5, close parentheses, use the 10, put the 4, and then you go minus parentheses, 1.5, close the parentheses to the 10, plug in your 3, and so forth. Okay? And then you guys should all be trying this on your calculator. You guys should all try this on your calculator, and then I'll be walking around to check your calculator. All right, so you guys should have had like negative 1.5625, right? Yes? Did you guys all get that answer? Yeah? Okay. So now that I have that, I know I'm going to need it again. So I'm going to highlight this one because I know I'm going to need it. So I'm going to now plug in my equation. My function rate of change formula is f of x2 minus f of x1 over x2 minus x1. Equals. All right, I want, I'll do lefties. Lefties, tell your partner, what are we going to put in the numerator? Let's blank minus blank. What goes at the top? Lefties, practice with your partner. Which one's f of x2 minus which one's f of x1? Okay. And then righties, tell your partner what goes in the denominator. Blank minus blank. Okay, ready? So for f of x2, Alondra, tell me what I put for f of x2.
Negative 1.5625
minus 2. Thank you. Over the denominator now, blank minus blank. Natalia? 1.5 minus 0. Good. All right, and those four numbers came from here. F of x2 minus f of x1 over x2 minus x1. And then you basically just calculator work from now. You're going to do negative 1.5625 minus 2. That's just going to be a negative 3.5625. over, what's 1.5 minus 0? 1.5. So go put that in the calculator. Negative 3.5625 divided by 1.5. You should get like a semi-long, it keeps going, right? Forever? No? Oh, I'm thinking of the graph. The next one does. I think, oh, you're right. This one stops at the third decimal, right? Double check with your partner. Righty side partner, what'd you get for your answer? Okay, ready? Omar, can you tell me what's your answer? So I'll come back to you. Lupita, can you tell me your answer? They're still working on it? Okay. Alexa, what'd you get for your answer? Oh, sorry. You Lupita or something? 9375? Alexa, did you get the same answer? What did you get for your answer? 7.5? Yeah. Omar, what'd you get?
Negative 2.375.
Okay. So Lupita, I'm not sure how you plugged it in, but I believe this is the correct answer, this one. So double check. I'm not sure what happened, but the answer is negative 2.375. Okay. Thank you for helping her figure out what she's doing. All right, so then remember for the answer, we got to say the average rate of change between 0, 1.5 is negative 2.375. That to 3 decimal places, which so after the decimal, 3 numbers. So 3 decimal places, after the decimal, 3 numbers. So that is the final answer then. Okay? All right. I think the bell rings at 31, right? So 17, 18. Okay, we're going to stop here. We're going to have to finish this lesson tomorrow.